Welcome to uh, our lectures. Now, today we are going to start the second part of this course, that is power facts and power quality. So, in the facts, we have covered up to the series compensation. Now, from today, we are going to discuss power quality. The second part of the course is the power quality. So, let's we start the power quality. What is power quality and what is the need of power quality? From where the word power quality comes into the picture in the power system, and what is the need of study to power quality? Okay, some these are some questions. This power quality is newer, and at the same time, in the past, the power quality issues are not there. The reason is that nowadays we are using many non-linear load. Earlier we are using only the linear load, like say resistive loads are there, balance loads are there. But nowadays, because of the automation, because of the some advancement in the microcontroller, microprocessor, and thyristor family related control devices, definitely these are the one of the issues which is going to uh, uh, introduce this course is a power quality. So what is that power quality? The power quality is because of one is the use of microprocessor based control, or it may be the thyristor based control. It may be the thyristor based controlled systems. Some we are going to control, even we have replaced our fan regulators. Say suppose this is the fan, and which is connected with the some resistive regulators. So there are some resistive regulators are there, and with the help of some resistive regulator, it is possible to control the speed of fan. Now, but this resistive regulator is replaced by the thyristor based some regulators are there. So at a small level, we are replacing our linear load by the some non-linear load. Second is that because of the energy efficiency, energy efficiency it is the people are very much aware about the power losses. Now, what are the new machineries? What are the new controls should be used to do the energy conservation or to reduce our consumption? So this is one of the reason. And as we are moving toward the energy efficiency, definitely the systems are very much sensitive, or the controls or the machines are very much sensitive with the quality of supply, quality of voltage, quality of current, and overall, say, quality of the power. So because of this one, energy efficiency, this is the second issue. Because of energy efficiency, the users are very much aware, or it is very aware about the power quality. At the same time, the utility also giving some information about the power quality, and say the issue of the power quality is related by the non-linear load which is effect over the different equipments. So this is the one issue or awareness among the user. So it increases the issue of power quality. Okay. So, but what is power quality? Power quality is related with power quality is related with the voltage quality. Voltage quality. What is the voltage quality? The waveform or the voltage should be sinusoidal voltage, and it is symmetrical to the axis. This is time t and this is voltage. So V maximum should reach at pi by 2, and it is goes to the zero value at pi, and again 270 degree and twice pi, or it is equal to the 360 degree. So the voltage waveform should be a sinusoidal. It should not be a shifted upward or downward, means there is no DC offset is there, or there is a voltage waveform related to the voltage waveform related to the magnitude of voltage throughout the operation of equipment should be constant. So it is called as a voltage quality of the system. Whereas the current quality the current quality is that, suppose this is the voltage waveform. This is the voltage waveform. So current should be in phase with the voltage. Current should be in phase with the voltage, means the magnitude of current may be different. It is depend upon the load and how much the load over the system. Whereas it will follow the same path, means it should become maximum when the voltage is maximum. It should goes to the zero value when voltage is goes to the zero value, and this is called as a current. And if there is a deviation in the voltage waveform or the current or this magnitude, any say any disturbance or any deviation between the voltage and current is nothing but the power quality. So any deviation with between voltage and or current, it is called as a power quality. So it is not the meaning that current multiplied by voltage is the power quality, but power quality is any deviation. It may be in the magnitude with respect to the time in the voltage, or there may be some deviation in the current or frequency. Say it is a 50 hertz and this frequency, current frequency is not a 50 hertz. So any deviation between the voltage and current is called as a power quality. Okay. So this is called as a, simply it is called as a power quality. But the power quality or the quality of supply, and it's give the quality of supply. Quality of supply. So what do you mean by quality of supply? It has two parts. One is the technical part and second is the non-technical part. So first is a technical part. Technical, and it is non-technical. So technical is a voltage quality. Voltage quality, may be current quality. Okay, but when there is a power, we are power quality or sub quality of the supply, we are calling only the voltage, because the current is depend upon the load. What type of load? Either is a inductive, capacitive, or resistive load, or it may be some thyristor family control load is there. So the current is mostly depend upon the load, and how much current is drawing, again it is depend upon the load, whereas which is purely related with the supply is the voltage quality. So the technical part is the voltage quality, whereas non-technical part is the, we can call as a quality of supply. Okay, so it is a quality of supply service. quality of supply service. This quality of supply service means how fast the complaints are going to rectified, how many complaints are there, and how the complaints are going to overshoot, or it is cleared as early as possible, or it may take the time. And second is the tariff, electric tariff. So either the tariff is transparent. Transparent means the utility giving clear signal or clear identification or clear text to the consumer that this is the electric tariff for the different type of consumer, and the method of calculation, calculating electric bills is the electric tariff, isn't it? So the quality of supply is the non-technical part, but it play a very important role in the quality of supply. It is a quality of supply. It comprises of compliance, or it may be some say troubleshooting by the say how they are fast in doing some rectification in the documentation for the different type of consumers, and there are all these things. Then electrical tariffs are there, isn't it? Whereas for the technical part, it is a voltage quality. Now, it is also important to from this is the quality of supply, isn't it? This is the quality of supply. Similarly, the quality of consumer or consumption. Second is the quality of consumers, isn't it? Consumption. So again, it is two part. One is the technical part, and second is a non-technical. In the technical, it's a current, because consumer going to consume the power, and definitely its electrical equipments or electrical gadgets is drawing the current. So which type of current it is drawn by the consumer? So it may be a either it is a sinusoidal, it is a pure sine wave, or we can say that it is creating pollution in the system. So it is either is a non-polluting, or producing harmonics in the system, or it producing the harmonic current. Say, what is the harmonic current? Suppose this is the fundamental current component of the current. Say this is the fundamental component, whereas the current contains multiple frequency components of the current. No doubt the magnitude of current will be smaller. This second harmonic, third harmonic, fifth harmonic, seventh harmonics are there. And because of this, the final waveform of the current is not sinusoidal, because of the large harmonic component present in the current. So this is a non-sinusoidal resultant current is there. Okay. So it is the technical part of the quality of consumer. Either it is producing harmonics, or it is producing, say it may be a constant, it is a balanced load. Suppose the consumer is comprising single phase as well as three phase, and load is not balanced properly, so it will produce the unbalance in the power system. Second is the power factor. Power factor is going to maintain with the help of reactive power, and at the same time, if you draw more reactive power or more reactive current, so definitely it is the quality of consumer. He or she is not maintaining, the consumer is not maintaining the reactive current or reactive power, and hence the power factor of the system is a poor power factor. Then it is an unbalanced system. Large number of single phase loads are there. Even though there is a large number of single phase, but the connected load is not distributed well, and hence it's producing the unbalanced current, unbalanced voltage, and because of this unbalanced voltage is there. Power factor is poor, more reactive current is going to drop by the single phase load, or say it may be some induction machines are there. So this is the technical part of the consumer, and because of this technical part of the consumer, it also makes some pollution in the power system, and it also equally shares or equal responsible for bad quality of power supply, isn't it? Whereas how fast electricity bill is going to paid. So it is how fast electricity bill paid. Okay. So it is very important, if the consumer is paying electricity bill in time, so the utility will have a funds to enhance the quality of power supply, or it may be some support their complaints, or they improve the tariff and all these things. So this is the second part, that is a non-technical part of the power quality. So what is the power quality problem? So it makes an issue of power quality problem. Power quality problem. So first is the voltage quality. Then as voltage quality, this is current quality. Then power quality. Power quality is not the multiplication of voltage and current, just like a power, P is equal to V into I cos phi. Whereas power quality is the any deviation in the current, voltage, and frequency is the power quality problem. So a power quality problem is a occurrence of non-standard voltage, current, or frequency deviation that leads to misoperation or failure of end user equipment. So this is the power quality problem. Because of any deviation or any non-standard voltage, current, and frequency deviations are there, and that leads to the misoperation of equipment or failure of equipment. Say, for example, a farmer is using electric pump. So without any appreciable load on the pump, it found that the pump is going to burn out, or there may be a large number of tripping in the electric motor pump set. It is due to the harmonic in the system. it is due to the voltage unbalance in the system. It may be due to the under voltage system. So under voltage, when there is under voltage and constant load is there, motor is going to draw more current. And this more current, even though the load on the motor is not appreciably overloaded, motor get hit up and it is going to burn out, or it is going to damage the say motor winding. It may be due to the harmonics, multiple harmonics are there. So these all points is related to the power quality problem. Okay, so this is something which is a very basic one. What are the different type of power quality problem? The power quality, different power quality problems may be like that. It is a transient. It may be a transient. It may be a short duration voltage variation. It may be a long duration. Voltage variation. Now, waveform distortion. Waveform distortion means the waveform is not sinusoidal in both voltage and current. Then voltage unbalance. Voltage unbalance, voltage flicker. So these are the power quality problem. It may be a transient. Transient has two types. One is the impulsive transient and second is the oscillatory transient. We'll see one by one. Short duration voltage variation is there. The occurrence of change in voltage for the small period of time. Long duration, it may be an interruption. Waveform distortion. The waveform is not sinusoidal, but somewhere it is a square, just like a square wave. Voltage unbalance, it is because of the single phase load, large number of single phase. It may be a welding transformer, it may be an electric furnace, or welding machines are there, large number of welding machines, large number of electric furnaces are there. So it will definitely make the system unbalanced, or voltage flickers. So these are the some problems which is called as a quality power quality problems. Okay, so we'll see it is what is the in the four, there is a four major reasons for the power quality. So whatever the new equipments are there, so new equipments with is microprocessor based control and is a power electronic devices, and which are the non it is a say it is a not linear load and is more sensitive for the power quality variation. Definitely when we are using the microprocessor or an electronic base, it is more sensitive with the voltage variation, unbalanced voltage, frequency variations, and spikes, or it may be a transient in the voltages. Definitely it is going to burn out. So the peoples are very much aware about the power quality. They need power quality. The voltage and voltage waveform should be a proper one. The change in voltage should be in the permissible limit, because their equipments are very sensitive, and again it is very costly, like medical instruments are there. It may be some research based labs are there. Definitely the equipments are very costly and very sensitive, because the results is going to deviate from the actual values. Second is the increasing the emphasis over the overall power system efficiency. This is very important. The people are aware, and people are very much say conscious about the energy consumption, or the energy efficiencies are there. They are purchasing some say energy star rating equipments, and when they are purchasing electrical, say B energy efficiency make some star rating equipments, those are very sensitive in the voltage variation and the frequency variation. So it is one of the reason that the people are thinking towards the quality of power supply. That has results in the growth in the application of devices such as high efficiency, adjustable speed motor, instead of using some gear drive, which will lead to the more power losses. We are in the use of variable frequency drive or adjustable drives are there. And these adjustable drives definitely produces harmonic in the system. So this results in the increasing harmonic level on the power system. So no doubt, we are going to increase the efficiency of the system. At the same time, the power system is get polluted. That polluted is nothing but the harmonics. Second important point is that end user has increased awareness of the power quality. This is one of the issue. The people are aware, people are educated toward the quality of the supply because they are using quality of the electrical equipment. They are using energy efficiency equipment. So the people are. Many things are now interconnected. Because many things are interconnected, they are depend upon the continuity of the power supply. Therefore, the quality of power supply, it's maybe a technical part of the power quality of the supply and non-technical, that is quality of the service, then electric tariffs and all these things which is related. So these are the some major 4 points. There may be other points, but these are the major 4 points, which is which makes the question of the power quality. So what is the power quality? There can be a completely different definition for the power quality. Why it is different? Because the thinking toward the one frame of reference is different, but it can this depend upon the one frame of reference. What is the meaning? It means that for a consumer, the power quality issue is different, and for the utility power quality issue is different, and for the different type of consumers, which is say medical instruments, some research lab instruments, they are very much sensitive with the change in the voltage. So in perspective of the different consumer, different user, the power quality problems are different, isn't it? So for example, the utility may define the power quality as a reliability and show the statistic system it's a 99.98% reliable. So as in view of utility, the power quality is the reliability. There is a continuity of the supply. Reliability is that. So reliability is play a very important role in the frame of reference, in the utility frame of reference. Whereas the consumer frame of reference, the power quality is the voltage, where there should not be any deviation in the voltage. There should not be any some transient or interruption or say frequency change. It is related to the consumer. So in every prospect, a different power quality we can define this. A manufacturer of load equipment may define the power quality as those characteristics of the power supply that enable the equipment to work properly. So suppose any manufacturer is there, say manufacturing three-phase induction motor. So manufacturer is going to define the power voltage variation is 2% plus or minus 2%. The current is plus or minus 2%, or say if speed is frequency is plus minus 1% and so on. So at what is the range of voltage at which the equipment is going to perform very well or very satisfactorily. So from the utility perspective, the power quality definition is different. For the manufacturer, power quality definition is different. And for the consumer, the power quality definition is different, isn't it? So these are the different power quality definitions are there. But in a very simple way, the power quality definition is, in our perspective, very simple. Any power problem manifested in the voltage current and or frequency deviation that result in failure or misoperation of consumer equipment. This is our simple definitions, and which say make umbrella in the utility, in the consumer, as well as for the manufacturer. So any deviation in the voltage, current, and frequency non from the standard value or deviation that result in failure or misoperation of the consumer equipment, it is going to work. Say for example, in the power system protection, because of the power quality, because of some harmonics, our equipment is going to malfunctioning. There may be not be any much more difference in the current, but your circuit breaker is going to operate, it is going to trip the power supply. So this is misoperation. Similarly, there may be a failure. Even though the load on the three-phase induction motor is not high, not say overloading, even though under the small load or under the normal load, the motor get burned out because of the, so this is the consumer perspective is there. So this is a very simple. Any deviation, it may be a voltage deviation, it may be a current deviation, it may be a frequency deviation. In anywhere in the deviation in one of the quantity or any two of the quantity, it will give the power quality issue. What is the power quality problem? So this is, so the power quality, the quality of supply, and quality of the consumption. So quality of supply is the voltage quality. One is the technical and second is the non-technical. In the technical, voltage quality, either the voltage is sinusoidal, voltage is constant throughout the operation time, the waveform is constant, there should not be any deviation in the waveform, there should not be any deviation in the maximum voltage and say average voltage. So voltage, the magnitude is constant, the low voltage is balanced in all three phases. So these are the voltage quality, and that is nothing but the technical one. Whereas non-technical is a quality of supply, compliance, and tariff transparency. Either the tariff is very clear for the different type of consumer, but because the consumers are different, their application of the energy is different. For the residential is different, for the commercial is different. Similarly, it's a small scale industries, some medium scale industries, some seasonal industries are there. So the tariff should be a very transparent. So it is a non-technical part of the quality of the supply. Similarly, the quality of consumption is very important because the current which is related to the type of consumer or the consumer perspective. So it again, there is a two part. One is the technical and second is the non-technical. In the technical, either the consumer producing harmonic or it is a non-polluting. Definitely, which type of load is there? Either it is making unbalance, the power factor is very poor, it means that it will draw more reactive current. Similarly, the non-technical part, how fast respond to the electric bill. Definitely, when the electric bill is going to collect, means the when the funds are there, definitely the utility is going to maintain or increase the reliability and the quality of the power supply. So for today's, this is the introduction of our power quality.